6. Okay, so today is angles formed by chords, secants, and tangents. Make sure that you're going through defining those. Use your pictures for a secant, and then use a picture to summarize those two theorems. Okay, question 4 on page 614. It's a pretty good question as well. So get that. Okay, so here we go. So secant. A secant is a line that intersects a circle at 2 points. Okay. And when you guys start studying start studying trig in more detail next year, we went through the 3 functions this year: sine, cosine, tangent. There are 3 other trig functions that we'll go through next year. It's your secant, cosecant, and cotangent. Okay, the secant goes through a circle, hits a circle in 2 spots. Okay, it could be a ray from A to B. It could be like if we labeled, say, this point and this point and called it C and D. It could be a segment CD, which is a chord. That would be a part of a secant. Okay, it could be, so that would be a secant segment. It could be a line AB. Okay, so does a secant always contain a chord? Yeah, it has to. By definition, a secant has to contain a chord because it hits a circle in 2 spots. It goes through the circle in 2 different spots. Okay? Any questions on that? How many of you are still defining your theorems? Okay. So we have our first theorem, 12-12. How many have that one down? Okay. I'll give you a minute there to finish that one. That's theorem 12-12, and then I'll get 12-13 up there. Okay. So the measure of an angle formed by 2 chords that intersect the inside of a circle is half the sum of the measures of the intercepted arc. Go ahead, Gracie.
Why would you, so like when you're trying to find the angle 1 right there, why would you want to find that? If you already knew what x was, you wouldn't need, like,
that's a good question. Say the center of our circle's right there.
Oh.
This is not a central angle. So we don't know what x is. Like, if we knew x, it doesn't tell us what 1 is necessarily.
Okay. Yeah, I forgot about that.
Everyone understand the question she just asked? In a circle, don't confuse these angles that we're dealing with here with a central angle. Okay, I know central angle is a way cool angle because it's central and all, but okay, this is, let's say that's 60 degrees. Okay, it's really tough to see there. Okay, let's say that's a 60-degree angle. That makes this arc 60 degrees, or vice versa. This angle right here isn't a central angle. So we don't know what 1 is based upon x. Okay? But the relationship we have here says that if we could find out angle 1 if we know x plus y. Okay, x plus y cut in half gives us angle 1. Okay? And the other theorems you have are really similar to it. The other ones, this one deals with chords. Theorem 12-13, the 3 pieces that go with it, the measure of any angle formed by 2 segments, 2 tangents, or a secant and a tangent, and a tangent drawn from a point outside a circle, is half the difference of the measure of their intercepted arc. So if you're looking at that and you're taking and focusing in on these 3 different situations, you have 2 secants intersecting, you have an angle formed. You have 2 tangents intersecting, you have an angle formed. And you have a tangent and a secant intersecting, and the angle formed. Notice the angle in this one is always outside of the circle. Okay? When you're comparing the 2 different formulas, if I put all those formulas up there at once, and you're looking at the different pictures involved there, I wish I could get that outer edge to focus more. I don't know why it won't, but it never does. So, okay, if we're looking at those, notice if the angle's inside, it's adding. Otherwise, the formula is the same. If the angle's outside, they're subtracting the 2. Okay, inside, you're adding the arcs together and taking half. If the angle lies outside, you're subtracting the arcs and taking half. Okay, so inside add, outside subtract. I like to think of it as the bigger words go together. That's how I remember the formulas. Okay, outside, subtract, inside, add. Okay. I'm going to try some problems together. I'm going to let you finish getting those copied down, though. Now let's go through these examples. So this is off your worksheet, example number 1. I want everyone to calculate what x is, and then I want you to do the same thing for number 2 there. Okay, use your formula, show work, please. Using the formula, measure of angle x is equal to 1/2 angles inside. So it's, what is it?
110.
Good, 110 minus 80. Okay?
Wait, no. Isn't it
No?
It's adding.
We're adding?
Addition?
How do we know if we're adding or subtracting?
It's inside. It's inside.
If the angle that we're trying to find is inside or outside.
Good. If the angle we're trying to find is inside or outside, so you somehow have to make it clear in your mind when you add or subtract. This is going to be the tough thing on this lesson. This one is actually adding. Okay? If it's inside, we're adding. If it's outside, we're subtracting. If the angle you're looking for is, or if the angle you're dealing with is on the outside, you are subtracting. Yeah?
You could say, like, if it's on the inside, since they're always like intersecting, it's like a cross.
It's like a plus sign.
Yeah.
That's a good thing. You guys catch that?
Go Lily.
Man, Lily's stepping it up. It's like a plus sign in here, so you're adding. Out here, there's no plus sign. Well done, Lily. Sheesh. All these years and no one has ever said that. Good thinking. I know. All right, 190. So half of 190 is 95. Okay, very good. All right, and so this one means we're subtracting. So we've got the measure of angle x. So x is equal to 75 minus 15, all cut in half or divided by 2. You can even do it that way if you wanted. So x is equal to 60 over 2 or 30 degrees. Somebody got that?
Yeah.
Well, don't I? Questions on it? I'll let you know. Let's try these 3 problems. 7, 10, and 11. Okay, here we go. So let's start out with 7. These are a little more complex. Let's walk through them. You've had a chance to look at them. But on number 7, what formula are we using? Volunteer.
12.
Nick? Using subtraction. So we're saying,
X equals.
so is it x this time that equals?
No, it's 48.
It's 48. So our angle, so in this case our given angle, 48 is equal to
1/2.
1/2. We know we're subtracting, right?
Yeah.
Our 2 arcs. This arc and this arc. So the bigger arc minus the smaller. So the smaller is x. What's the bigger?
96. Why?
No.
The smaller goes from there to there.
96? It'd be Y.
Yeah?
Wouldn't it be like 360 minus x?
It would be 360 minus x. It's your entire circle minus x. So our entire circle degree is 360, and we subtract out what we know. So to keep it in terms of x, we say 360 minus x. Okay?
Minus X.
So we get 360 minus x minus x. So we have this 360 minus x and then that x. So that's actually 360 minus 2x. That's equal to 48. So how do I solve that? Let's get our algebra skills back. What do we do next? Get x by itself, isn't it?
We could do the 1/2 of 360 minus 2x, which would be 180 minus x.
So you're distributing?
Yeah.
Okay, that's one route to go, 180 minus x. Okay? Another route is you could have multiplied both sides by 2, and that gets rid of that 1/2 as well. But since we've said this route, we're going to actually distribute that. Good? Now what? Add x.
Now subtract 180.
Subtract 180? Doesn't matter, either way. So let's subtract 180. Let's keep x where it is, and we'll flip signs at the end. Okay? So we get 48 minus 180.
Negative 132.
Negative
132.
132 equals negative x, so positive x equals
132.
132. X equals 132. Well done. A little tougher, right? Yeah. Okay. Any questions there? So number 10, are we adding or subtracting? Okay, we're adding. Okay. So our formula is going to be something plus something times 1/2 equals something. So this angle right here, since we're given these two arcs, we're adding those two. That equals this angle. So what do we want to call that angle?
Y.
So we're going with y. Can we think of a way to call it, something to call it in terms of x?
180 minus x.
Yeah, you got it. Which would actually be what? 180 minus x. Okay, this is a straight line. So the straight line equals 180. If we subtract x, we get that angle. Right? So 180 minus x. So 180 minus x is equal to 1/2 72 plus 76. So this angle is equal to 1/2 of those two added up.
So wouldn't that just be that angle? It wouldn't be.
What's that?
Wait,
Well,
wouldn't you just find that angle first? Like you wouldn't have to have that 180 minus x.
you could. So the other route is to call this y.
And then you would subtract.
Then you'd subtract it from 180,
Okay.
which would be the same thing that you're...
Okay.
Okay, so if it makes sense, like if that's confusing you, then think of it like that. And once you know y, then you can find x. Everyone see that? Once you know y, x and y have to add up to 180. So if we go through this and solve, 72 plus 76 is what? 148.
74.
Okay? And 1/2 of 148 is 74. So if y is 74, okay, so this angle right here is 74 degrees. What's x?
106.
74 and x have to add up to 180. What's that? Yeah, so you subtract 74 from it. That's going to give you x.
You just find 74 by adding them together and dividing it by 2, and then you just times it. You don't divide by 2, you just have 74 times 2, and then you take 360 and just take away 74 times 2.
That's way too complicated.
You could.
Yeah.
Yeah, you're making a circle there then. That's fine. Yep. Okay. Any other questions there? Hannah, you should knock people's ideas. Okay, nice.
What?
Don't knock his idea. He was just going in a circle. He's just talking in a circle.
I hope he has fun like writing everything down on his paper.
Hey, let's try number 11. Are we adding or subtracting?
Subtracting.
Subtracting. It's 1/2 of that minus that. What's this one?
X minus.
So big arc minus small arc. So big arc minus small arc. What's the small arc?
Oh, it's 360 minus plus 240. Why do I have one of these?
Lee?
20 minus x.
What's that?
20 minus x.
220? How did you get 220?
360 minus 220 minus 220.
Okay, so you took 360, you subtracted 120?
Yeah.
Okay. Minus another 120.
Yeah, equals 120 minus x.
Okay, so that gives us how much left? 120? And that 120 degrees, you're saying you have to split between here and here?
Yeah.
Everyone see that? There's only 120 degrees left, and it has to be split between here and here, and we've already used x of it up. So that means this has to be 120 degrees minus x, minus what we used over here. Okay? Everyone with that? Okay? So this is 120 minus x. Now there's a problem right there in the way I wrote that. Anyone catch it?
Use parentheses.
Andrew?
Yeah, don't the x's cancel out?
They do right here, but that's because I put it in. I didn't write it correctly in there. So everyone watch again. This will be a common mistake. Okay? That's what I had. I'm subtracting 120 minus x. Nick, what do I need to do there?
You put that in parentheses.
I need to put this in parentheses, and that's a big deal. Because now it's like you're distributing a negative. Okay, so that's actually 1/2 of x minus 120. Negative times negative is positive, plus x. So that actually gives us that 1/2 x, excuse me, not x, 1/2 times 2x minus 120. Everyone with that?
Yeah.
Okay, and our y, we should have changed that early on. That should have been 28. Right, didn't put that in. 28, 28. I'm going to double both sides this time. Just multiply by 2. That gets rid of that 1/2. That's not 52, it's 56. Then add 120. 176, and divide by 2. X is 88. All right. Your assignment is the mixed side of the worksheet. Okay? Make sure you're asking questions. A lot of formulas you have this chapter. Get them copied into your notes.